Hi and welcome to Demystifying Math. This is part 2 in a video series on surface of revolutions. In this part we're going to be concentrating on graphs that have been revolved about the x-axis and finding the surface area that's generated. Our first example, we have 1/3 x to the third. We want to find the surface area that's generated by revolving that curve from x equals 0 to x equals 2 about the x-axis. We have a formula for the surface area. If you need a proof on how we got the surface area formula, that was done in part 1 of surface of revolutions. Okay, in our formula we have f of x, and we also need the first derivative squared. So let's go ahead and find our first derivative. So multiplying 1/3 by 3 and reducing our exponent by 1, we end up with x squared. Then we need to square our first derivative, so that gives us x to the 4th. Now we're going to plug into our surface area formula. Our endpoints of integration were given as 0 and 2. F of x is 1/3 x to the third, and replacing f prime at x with x to the 4th, we ended up with the square root of 1 plus x to the 4th. Now we need to integrate this, so we're going to use some u substitution. We're going to let u equal what's underneath the radical, 1 plus x to the 4th. Then take the first derivative of that, so we get du equals 4x to the third, or we can rewrite that as 1/4 du. We did this because x to the third is in our formula integration, and we can do direct substitution by replacing x to the third with 1/4 du. But before we do that, let's find our new endpoints of integration in terms of u. So using our formula for u, which is 1 plus x to the 4th, we're going to plug in our 0, which gives us 1, and 2, which gives us 17. So 1 and 17 are our new endpoints of integration. Replacing the x to the third with 1/4 du, and our 1 plus x to the 4th with u, we end up with 1/3 times 1/4 times the square root of u du, all multiplied by 2 pi, and our new endpoints of integration at 1 and 17. Let's go ahead and simplify the fraction a little bit. So we have 1/6 pi times the integral from 1 to 17 of the square root of u du. Okay, so now we need to integrate in terms of u. So we have u to the 1/2, and adding 1 to our exponent, we get 1/2 or 3/2. Dividing by 3/2 is the same as multiplying by 2/3. So now we need to plug in our endpoints of integration. We plugged in the 17, and when we plug in the 1, of course 1 to any power is 1, so we just left with 2/3. Then I went ahead and factored out the 2/3. So I have pi over 9, 17 to the 3/2 minus 1. This gives us our surface area of 1/3 x to the third revolved about the x-axis between the values of x equals 0 and 2. We can go ahead and estimate that on our calculator. We get about 24.12, and the units squared, because this is area, it's going to be square units. Okay, let's try one more example. We have the equation square root of x, and we want to revolve the square root of x about the x-axis between the values of x equals 4 and x equals 9. So again, our first order of business is to find the first derivative of the square root of x. So reducing our exponent by 1, we get x to the negative 1/2. So 1/2 x to the negative 1/2. Then we have to square that. So we have 1/4 x to the negative 1, or rewriting as 1 over 4x. Then plug into our surface area formula. So we have for f of x, x to the 1/2, for f prime at x, 1 over 4x. Our endpoints of integration were given as 4 and 9. Alright, so we need to figure out a way to integrate this. So I'm going to find a common denominator between the two terms under the radical, which is just 4x. And I'm going to rewrite them as one fraction. And now I notice that I have a square root of x, and then in the fraction under the radical, I also have a square root of x and a denominator there. So I'm going to pull that out from under that radical. And now I notice that the square root of x's are going to cancel. In addition, the 2 next to the pi and the 2 in the denominator are also going to cancel each other. So we can simplify this to the square root of 4x plus 1, integrating from 4 to 9 and multiplying by pi. Okay, so now we need to integrate this. So we have to use some u substitution again. We're going to let u equal what's underneath the radical, 4x plus 1. Therefore, du is just going to be 4 dx, or 1/4 du equals dx. Again, we need to find our new endpoints of integration in terms of u. So plugging into the u formula, the 4 first gives us 17, and the 9 is going to give us 37. Our new endpoints of integration are 17 and 37. Plugging into our surface area formula, we have the square root of u du. Our endpoints of integration of 17 and 37. And I brought the 1/4 next to that was multiplied by du out from outside the integral, so I have pi over 4. Now integrating the square root of u, we have 2/3 u to the 3/2, and then we're going to plug in our endpoints of integration. So we get pi over 6. I multiplied the pi over 4 by 2/3 to get pi over 6. 37 to the 3/2 minus 17 to the 3/2. And we can estimate that on our calculator. So we get about 81.14 units squared. Okay, thank you for tuning in to Demystifying Math. We're going to have a third video where we will be working on revolving about the y-axis.